Welcome to the 24th episode in the mathsonlinetuition.com videos. We're starting off with chapter 8 and it's entitled Graphs of Geometric Functions. This chapter is going to be divided into two videos because I think it's vitally important that you appreciate this principle. It will come up more in A2, so I think for that reason we need to pay close attention to the content that we're about to endeavor towards. So you need to be able to use the three basic trigonometric functions for any angle. In one of the videos I referred to this as SOHCAHTOA. I'm not sure if this is something that is taught in schools, but it's something that I have definitely taught students. It's the SOHCAHTOA. Okay, SOHCAHTOA. And SOHCAHTOA enables you to appreciate that sine equals the opposite over the hypotenuse, and that cos equals the adjacent over the hypotenuse, and that tan equals the opposite over the adjacent. SOHCAHTOA. And another thing that you can utilize to remember this is mnemonics. Mnemonics, I've spoken about mnemonics a number of times. If you go onto the mathsonlinetuition.com videos, mathsonlinetuition.com website, and you go to the interactive tab under blogs, you'll see there's a number of blogs written about mind mapping and mnemonics, which is very, very important, and I can't stress it more highly. Right, so another way that you can use is you can utilize a simple story to enable you to appreciate this. If you can't remember how SOHCAHTOA is spelt, then you can, for example, use a little story. In this particular equation, you can say, you can create a story where words are represented using the letters here. Just an example, Susan once had children at her trees, orange something. I hope I'm getting the point across. So Susan once had children at her trees, orange, I don't know what A would represent, but essentially that's a story. So now when you write it out, if you forget it, you can say Susan once had children at her trees, orange, and A will come back to something to represent A later, but you can say COHCAHTOA, which will revert back to SOHCAHTOA. Okay, just a small, simple example, a humorous example, just to illustrate mnemonics. And you can see that this is how it would be represented on a triangle. Opposite side is, as you can see, the opposite side of the angle. The adjacent side is the adjacent side of the angle, and the hypotenuse is what some people deem to be the longest side. But just remember that this is the opposite, this is the adjacent, and what's left is going to be the hypotenuse. And so you can figure this out. The line OP from the origin to the point P makes an angle theta with a positive x-axis. Draw diagrams to show the position of OP with theta equals, and then you have the following. Now remember, we said that with the graph, the movement in the positive direction here, okay, is in the counterclockwise movement. So you could say from starting from the right hand side of the graph, going to the left hand side, okay, and coming round. Okay, so when we start off, we go from right to left. That's when we start off at the x-axis, all right, but in other words, counterclockwise. This is the positive. Now the negative way of going, or the clockwise way, is this particular way, is the clockwise way, okay, and it's illustrated here. So you can make this example is trying to get you to appreciate a rough idea of visually what these angles will look like, okay? And you can also see they've given you them in radians. Again, how do we solve for radians? There was an equation, there was a formula which allowed you to convert from degrees to radians. Please do view it in previous videos. And again, XY plane is divided into quadrants. We discussed quadrants very briefly many videos ago. I will write them out once again here. This is Y, this is X. This is the first, this is the second, this is the third, this is the fourth. This represents 0 degrees, this represents 80 degrees, this represents 270 degrees, this represents 290 degrees, and once you come back from a full circle, obviously it will represent 360 degrees, okay? Now, if you go the other way around, then you have minus 90, minus 180, minus 270. The way you can think about this is essentially saying that the opposing neutrality, okay, the opposite neutrality. So you can see a positive here, negative here, okay? Positive, okay, this would be negative, positive, negative, alright? And so in this particular example, they're asking you to illustrate degrees exceeding 360, and that's very simple. All you need to appreciate is 360, 0, once you make a full circle is 360, and then what's left is 40. So just by showing the diagram is at the angle 40 will be sufficient, okay? And likewise here, 360 plus 340 is representative of 700. So you know that you're going to make a full turn, which is illustrated by this spiral, and then once again 340 comes all the way around, and is 20 sufficient of again completing another full circle, and 20 here is illustrated by this particular sector. And similarly in the negative manner. For all values of theta, the definitions of sine theta, cos theta, and tan are to be taken as follows. So sine theta yr, cos theta equals xr, and tan theta equals yx. So it's a SOHCAHTOA rule, but you can see now that instead of using hypotenuse, adjacent, and opposite, they're using x, y, r. X here is with regards to the x-axis, y with regards to the y-axis, and r is the radius, and then it makes the theta, which is the angle. And then again, just some terms here. Acute is, okay, this particular angle here, okay, and obtuse is again illustrated by this particular angle, okay? So where x and y are the coordinates of point P, and r is the length of OP, again the radius, since we're talking about a circle. So write down the values of the following: sine 90, sine 180, and so on. And we can write down the values, okay, by exhibiting the following. So you can see that P has the coordinates 0, r, so sine 90 is r over r. And the reason is because, well, if you look at sine 90, 90 is going to come here, so the angle is going to be a right angle. And then if we install it into our equation, you can see that, into our formula, you can see that we'd have r over r, which gives us 1. Okay, why? Because with the sine, opposite and hypotenuse, okay, or in this particular case it will be the y and the x will be r and r, okay? And so you can figure that out for the rest of those questions. Just also to be aware that in these examples they're working with degrees, but they're also giving you the radians for you to appreciate both of the different types of measurements for angles. 8.2, you need to know the signs of the 3 trigonometric functions in the 4 quadrants. Okay, so this is essentially informing you of the signs of the three sine, cos and tan in the four quadrants. Okay, and so you can see here that it's telling you as x is negative and y is positive in this quadrant. Okay, it's giving you an example. So it says sine y over r positive positive, negative positive gives you negative, and positive negative gives you negative. Again, it's very similar to what we've done before with the signs. The sign computation does not change. Okay, if you multiply a negative by a positive, you get a negative, and if you divide a negative, okay, by a positive, you get a negative. And again, they give you a handy way of appreciating this. In the first quadrant, sine, cosine and tan are all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. Fourth quadrant, only cos is positive. This diagram shows which trigonometric functions are positive in each quadrant. You might find it useful to make up a mnemonic to remember these results. For example, all silver toy cars. Again, even the book is utilizing the mnemonic methods, so please do remember it. It's very important, and you can see they've utilized it for you to remember how to recall what is positive or what sign is goes where for which trigonometric equation or which trigonometric sign in a specific quadrant. So here all of the quadrants positive. Here only sine is positive, so that means cos and tan is not positive. Here tan is positive, that means sine and cos is negative, and here cos is positive, which means that tan and sine is negative. And so here you have a particular example. Okay, show that sine 180 minus theta degrees equals sine theta. Okay, and so you can work through this particular example and you'll get an appreciation of what the question is asking. And then they have this result. The results for sine, cosine and tangent are as follows. So you can see that through this illustration and through this very handy table here, very handy list here, that you'll be able to appreciate the signs of the trigonometric equations when the angles are computed using a variety of different degrees. This is very important for you to appreciate and to learn. It's something that you should memorize, and also this graph should be written out because it will give you an appreciation of how angles will come to look like, and it will make your reaction time faster and your response time even more efficient for you to get through questions. Some examples for you to carry out. 8.3. You need to be able to find the exact values of the trigonometrical ratios. So you can see here that you can find the trigonometrical ratios of angles 30, 45 and 60 exactly. Consider an equilateral triangle ABC with side 2 units. If you drop a perpendicular from A to meet BC at D, then BD equals DC, which equals 1 unit. And you have the angle 30, angle 60 using Pythagoras theorem and ABD. So essentially what's happened here is using Pythagoras theorem, which remembers a squared plus b squared equals c squared. And then they also have the angles here, all three of them, right? And then through that you can utilize the ratios, okay, of the trigonometrical signs. So you have sine 30 equals such, cos equals such, and tan equals such. So then you can obviously appreciate the ratios of each of these signs to one another. Exercise D8D gives you more of an appreciation of this question. So 8.4, you need to be able to recognize the graphs of sine, cos and tan. And I think this is something that we're going to do on our next video, so we're going to stop there. So we want you to go over the ratio of the signs, also appreciating where in which quadrants the signs have a sign of are positive or negative, also appreciating the SOHCAHTOA rule, okay, and also understanding how to draw out the degrees, okay, and maybe revise also conversion between degrees and radians and vice versa for you to keep up to date with those two forms of measurements of angles. So thank you very much for listening, and we'll see you in our part 2 video on this chapter. Take care and goodbye.